Hi, welcome to this video on unit conversions in chemistry. So many students have what I would like to call a math phobia. They just think it's too hard to do. They kind of give up real easily. And I want you guys to know that unit conversions can be made really simple, and you'll be able to get them right every single time. So we're going to show you how to do that in this video. So in chemistry, we use a setup known as dimensional analysis to convert between units. There are a couple of terms that we need to know for this. The first term is unit, and units are types of measurements. So any type of measurement will work in dimensional analysis. You can think of a unit example of like pounds, grams, meters, liters, miles, kilometers, anything you can think of that can be measured, it always has a unit. In fact, all measurements have a number and a unit. Without the unit, the measurement is worthless. The other term that you need to know is given amount. The given amount is a given measurement, meaning it's given to you in the problem that only has one unit attached to it. So when we're trying to convert something like, say, 5 kilometers to meters, 5 kilometers would be the given amount. It's what you're trying to convert out of into another unit. Finally, you need to know what a rate is to do this. And a rate is a measurement with 2 units, usually stated as something per something, like kilometers per hour or meters per second or grams per milliliter, that is used to convert the given amount to the new unit. So you're given the given, which sounds stupid, and then you figure out the rate, and then do the math. And so that's what we're going to show you how to do, is how to set this up with a given amount times the rate to get the change. So the best way to learn how to do this is to look at examples. So in this example, it says how many meters are in 60 kilometers or kilometers. So I've put up a little table that really helps with this stuff, and you'll get similar tables for every test you take in my class, every quiz. You can use it on the homework, etc. So the table is really important, and I'm going to show you guys how to look at the table and how to use it. So if you look at the table here, you have symbols on this column, the prefix name on this column, and the multiplication factor in this far left column. So let's look at one that you guys might be familiar with, and that's kilo. So kilo has a little k as the symbol. Its factor is 1,000 times bigger than the unit. So it's like a kilometer is basically 1,000 times bigger than a meter. That also translates to 10 to the third in scientific notation. So when I look at kilometers, we can actually write it as km. The meters is usually written as m. And I use my table to figure out how to set this thing up properly. So the first step is to write down the given amount. So we have 60 kilometers. And I set it up like this, and there's many ways. If you look at other videos, you might see it set up like this, where they use what's called the railroad track method. You might even see the railroad track method with a multiply there. But the basic idea is we have 60 kilometers as the given amount. It's often written without the 1 underneath, so I don't usually write the 1. It's technically 60 kilometers over 1 with no unit, but I'm just going to get rid of that because I don't usually write it. Then I go to my table and I see kilo and 10 to the third or 1,000, however you want to write it. So whatever unit is here, kilometers, needs to go there. Whatever unit I'm converting to goes in the top right. Whatever I'm trying to get rid of goes in the bottom right. To get the numbers, I just look at kilo, that is 10 to the third. So that means that 1 kilometer is 1,000 meters in that case. So I always put a 1 next to the unit with the prefix, in this case kilometer. Kilo is the prefix for kilometer. And then math-wise, I just do 60 times 1,000 and then divide by the bottom. On the bottom we have ones, So it's 60 times 1,000 divided by 1. And that means our answer, as you guys can probably figure out even without a calculator, is 60,000 meters. Okay. And so that's how we're getting that setup done. We'll look at another example here just to kind of help you guys out. Okay, here's a second example. It says how many grams is 250 milligrams. So again, I set up my dimensional analysis. Setup. We're starting with 250 milligrams. Milli has the lowercase m. You can see that here. And grams is a G. So that's 250 milligrams. I put my milligrams at the bottom again because when you put units in the diagonals like that, they cancel out. So just like 4 divided by 4 equals 1, or 10 divided by 10 equals 1, x divided by x equals 1, milligrams divided by milligrams equals 1, and it cancels them out. So again, I put a 1 next to my prefix unit, and that's 1 milligram, and I go to the factor, and it says that a milligram is 0.001 grams. Now, you can write it like that, or you can write it as 10 to the negative third grams. Whichever is easier for you to put in the calculator when you're first learning this is the way to go, but they both mean the same thing. So then I just multiply 250 times 0.001, and then that's divided by 1. Now, when you divide by that many decimal places, you can technically take that 250, and this is why the metric system is so great, and all you have to do is just move it 3 decimal places. So in that case, it's going to go 1, 2, 3. That's going to be 0.250 grams. I don't even need to use a calculator to get these done for the most part, because all you got to do is move decimal places when you're doing these. Let's look at one more, and then we'll see how we are. Okay, let's look at this one. It says a teacher weighs 95 kilograms. How many milligrams does he weigh? Now, what you might notice in this one that might be a little different is we're starting in kilograms and we're ending in milligrams. We're not going to the base unit. The base unit is grams. So in this problem, we're going to have to do something known as a two-step dimensional analysis problem. So let me show you how this works. We're going to start with our given amount, as always, and kilograms, the short version, is kgs. And I'm going to set up a double multiply. And it's going to seem, like this might be more complicated. It is a little bit, but it still works the same way. So again, whatever unit is there needs to go there. And the next thing that you want to know is that anytime you're doing a prefix conversion like kilo to milli, you got to go to the base unit first, and that's grams. Grams has no prefix. That's why we call it the base. Okay. Now, if I have grams there, there needs to be grams there. And what the question's asking for is for us to convert it into milligrams. So again, whatever you're looking for, whatever it's asking in the question, that always goes there. Okay. So notice I put all the units first, and this is a technique that helped me get this down and get them right every time. If you put the units first, then it's just a matter of getting the correct numbers in every spot, okay? So again, the prefix unit gets a 1, and remember that kilo means 1,000 times bigger. I'm just gonna put it in standard notation, okay? Next thing I do is go to this section and put a 1 next to milligram. It's got the prefix, let me just put this here, the prefix unit always gets a 1 next to it. Okay, so then I go to milli, which is there, and again, milli means 0.001, or you can do 10 to the negative third, your choice. Okay, so in my calculator, I'm gonna go in a very specific order of how I put this stuff in. So the first thing I do is type in 95 times 1,000 times 1. You guys know you don't have to put the times 1, but just to show you the steps. I then hit the divide button, put 1, and then I hit divide again and put 0.001. Now, you're always allowed a calculator on tests and quizzes in my chemistry class, And so it's not too difficult to get these done correctly. So in the calculator, I'll do, just to kind of write out what I'm doing, 95 times 1,000 times 1. Again, I'm just showing the times when I don't actually do it. Then I hit divide. So I basically take care of the top portion first by multiplying. Then I divide by all the bottom portions. So I divide by 1, I divide by 0.001, and then at the end, I hit equal. Okay, so it's going to be 95,000 times 1 divided by 1, which, makes it 95,000, and then divide by 0.001. So again, I recommend using a calculator on this. So when I run that through the calculator, I get this number. And it comes out to 95 million. And again, the unit's going to be milligrams, and that's going to be my answer. So there are 95 million milligrams in 95 kilograms. I hope this video was helpful for you. You can like and subscribe to the channel. I honestly don't really care. I just want to help the students that need help for this. I will be putting out more videos on chemistry-related items, so make sure to check the channel for those, and check Google Classroom as well if you're in my class.